So the first thing that I would do is rewrite that. You're going to have to factor it. I made most of the ones on here something that you have to factor. I always try to make the study guide harder than the test. So the test won't be this hard, but I try to do that on purpose so that it's like, if you can do everything on here, the test will be kind of easier by comparison. But let's go ahead and rewrite this. First of all, it doesn't really matter where that -3 goes, but a lot of people, it bothers them if it's out front. So I'm going to write it at the end. And then also we're going to need to factor this. So it will be f of x equals, or y equals, whatever you want to put, -4 sine, and then leave yourself a little blank. We'll need to factor that. And then -3, if you want to put the -3 at the end. Again, that just usually goes over better if it's at the end instead of the beginning for whatever reason. So we're going to factor out the 5/2. So put a 5/2, start a parenthesis. When you divide out a 5/2, that's the same as multiplying by 2/5. Remember, you just flip it over. It's just the reciprocal. So if you multiply by a 2/5 through there, the whole point is these cancel. It'll just be x plus 2/5 pi, or 2 pi over 5. You can write 2/5 pi, however you want to put that. But it has to be factored for you to be able to see what the phase shift is. So if you want to block off the trig function, this part, that's what comes from the unit circle. And again, sine would be the y value. And let's go through and do the automatic stuff. What is something I can put on here that's just automatic, like I can just put the answer? What is the domain for sine or cosine? So here's my pep talk. Some of this material is hard. Some of these, bless you, some of these questions are hard, but they aren't all really hard. So make sure you get the easy ones, right? Amplitude, be really careful because it's not -4, it's 4. You have to absolute value that. The period, it's 2 pi over which number from this equation? Because I know there's a lot of numbers in there. Good, over the 5/2. So again, dividing by 5/2 is the same as multiplying by 2/5. So if you want to write that down, or you can do it in your head, that's cool, but you're going to multiply by the reciprocal. And then really all you have to do is 2 times 2 is 4. So 4 pi over 5, which is kind of weird. All right, phase shift. You have to look at the factored version. Did it go left or did it go right? Left, good. So you can say either left 2 pi over 5 or -2 pi over 5. And that's where this is going to start if you want to go ahead and put that there. Remember, if it goes left, it needs to be negative. And then what's the vertical translation? Yeah, down 3, or you could just say -3. All right, so for the range, what I would do is find where the center is. This moved down 3. And you know what? I'm actually going to put some little extra tick marks in here because otherwise we're going to go off the grid. But the vertical translation was down 3. So you would go down 3 and that's where the center is. You don't have to dot this in. That's like optional, but I do it just so I can see where the middle is. So the whole thing moved down 3. That's where the center is. And we said our amplitude was 4. So that means you're going to go 4 below that and 4 above that. So what is our range going to be? If we're 4 below that, let's see, what would that be? -7. And if we're 4 above that, where's it going to put us? 1, good. So I would dot in where the center is. You don't have to, but it moved down 3 and then the amplitude was 4. So we're 4 below that and 4 above that. So look, we filled all of that in and each blank is worth a point. We didn't even do the graph yet, okay? And my suggestion is do these f of x values first because they're easier. The x values, that's the hard part. Let's do this first. We're going to go around our unit circle. We're going to get the y values, multiply them by -4, and then subtract 3. All right, here we go. What's our first y value? 0 times -3, or sorry, times -4 would still be 0 minus 3. -3. Good. Now we're up at the top. What's the y value? 1 times -4 would be -4 minus 3, -7. Now we're over here at 0 again. That's going to give us -3. Then we're down at the bottom. It's -1 times -4 would just be 4 minus 3, 1, and then we're back to -3. Again, hopefully once you get the ball rolling, like it's cyclic, you can just keep it going. All right, so this is your phase shift. That goes right here. And then you're going to add the period. So what did we say the period was? 4 pi over 5. All right, -2/5 plus 4/5. 2 pi over 5. And that's actually kind of a sigh of relief, because what's halfway in between these? 0. And then halfway in between again would just be 1/5, pi over 5, and then this is negative pi over 5. Because that looked like that was going to be really bad for a second, like, oh my gosh, this thing is 2/5, but then it turned out not so bad. All right, and again, I try to make these harder than the ones on the test. Like I make the test and then I try to like make this like a little bit harder, so the test will seem easier by comparison. All right, after that, we just have to plot these. If you want each tick mark to be a 5th, okay, I realize it's been a week. How do I make sure each one is a 5th? Go to the 5th one and call it pi. And you can go this direction and call that negative pi. But now I know that each one of those is worth a 5th without having to label every single one. Please don't label every single one, okay? And then you're just going to put these points on here. -2/5 will be -3. So that'll be right here. And then -1/5 will be -7. And I'm going to stop reading them all to you because that's annoying. You guys just go ahead and put them on. And then I just want you to continue it for one more cycle. You can continue it as far as you want, but I just want you to do at least like one more cycle of the function. Let's see. I'm being real upfront with you. Here's how I do the grading. Each thing's worth a point, and they're 10 each. You ready? 1. Yeah, you get a point for writing all reals, right? 1, 2, 3, 4, 5, 6, and then 7 for the x's, 8 for the f of x's. That's 8, and then the graph is worth 2. That's how every single one of these is, all of them. All right, so looking at the study guide, we just did the one that was sine. I don't know why I put 2 on there that was cosine. I guess it was like extra fun, all right? It's going to be the exact same thing we did, except what? What's the only difference? You'll use the x values, that's it, okay? So now we're going to do a secant or a cosecant. So either 12 or 13, I'm going to do number 12. So let's look at number 12 together. So again, we're going to need to factor this, and I would write the 2 at the end. It doesn't really matter, but again, a lot of people just, they do better with it if the vertical translation is at the end. So let's rewrite this. It'll be f of x equals or y equals, you know, whatever you want to put, negative secant, and then leave yourself a little blank, and then I'm going to put the plus 2 at the end. And then what do we need to factor out from this? Pi. They're not all really hard. If you factor out pi, what's left? Yeah, x minus 3. See, some are more difficult than others. That one wasn't too bad. All right, so let's see what we can fill in. Unfortunately, not domain and range, but we will be able to do the rest of it. What's the amplitude, guys? None. If it isn't sine or cosine, it's none, like automatic. Period would be 2 pi over what part of this? Pi, good. So the pi's cancel, you just get 2, which is sort of nice. Phase shifts, 3, or you could say right 3, and that's what's going to go right here if you want to go ahead and put that. Your phase shift is always where you start. And then what's our vertical translation? 2, or you could say up 2. If you want to put the up, down, left, right in there, you can do that. These, unfortunately, you have to wait until you get your graph. Ms. Cole, what if I mess up the graph? Make something up. If this matches what you drew, I will give you credit for it. So again, it can be difficult, like they're not easy problems, but the way I grade it is really kind of forgiving, right? Let's do our f of x values first. If you want to block off the trig function, you can do that. That's the part we get from the unit circles. It's secant, so we're going to flip all the x values. We will multiply them by a negative and then add 2. You just have to do the stuff that's outside, right? So what is your first x value? 1. If you flip 1 times the negative will make it -1 plus 2 is 1. Now we're at the top. Your x value is 0. You can't flip 0, so what do you get? Undefined, which means what's going to be on the graph? Perfect. Now we're over here. It's -1. Flip that. It's still -1. Times the negative will make it +1. Plus 2 would be 3. And I'm going to sit down now because hopefully we can just kind of keep the pattern going. What's the next one? Undefined and then 1, and then undefined and then 3, and then undefined and then 1. Going to keep on going. All right, so now we need to get these. We start with the phase shift, and then you add the period. So what did we say the period was? 2. So 3 plus 2, 5. What's halfway in between? 4. And then halfway in between again. I'll take decimals for this. We'll do 3.5 and 4.5. If there's a pi in there, I really kind of like for it to be fractions because it goes a little bit better, but the pi cancel it out. So we'll take 3.5, 4.5. So if you want to label these by halves, just skip the first one and call the next one 1. And then I know each one in between is a half. And then you're essentially just taking that information and putting it on the grid. Do you remember what these graphs look like? These are the really bizarre ones. Do you remember like the U-shaped things? Yeah, like I call them smiley faces and frowny faces. All right, so we get 3, 1, and then an asymptote, and then 4, 3, and then another asymptote. And I just want you to keep it going a little ways. Now, I usually say it doesn't matter if you continue it to the left or the right. You're going to need to continue this one to the left because when we write the domain, you have to start with the first asymptote and it's the first positive one. So you have to make it back to the axis. So we're going to have to go this way. But I want to see at least 2 smiley faces and 2 frowny faces. And then just don't forget to go back and answer the domain and range. I would do the range first because I think it's easier. You're sweeping downwards to upwards. So it'll be -infinity to what? To 1, good. Union, we're missing this little part, and then it'll pick back up at 3. So 3 to infinity. Again, it's like you took the cosine graph and turned it inside out. Like you took that wave and just made it go the other way. So domain, you want everything except the troublemakers. The problem is there's an infinite number of them. So the way we write it is it's everything except, so all x not equal to, where is the first asymptote? The first positive one, or 0 if it's on 0. 0.5, it's at a half, all right, right here. So you can say 1/2 or 0.5. Plus, however often they're happening. So we have one at a half and then 1.5, 2.5, 3.5. So they're happening every 1n. So every 1n. And that is going to be here. I'll use a different color for this. That is always going to be half of the period. So whatever the period is, it'll be half of that. So the period here was 2, half of that is 1. All right, and then I want to do one tangent or cotangent one. Let me see which one I had circled over here. We'll do number 15. So again, you're going to want to rewrite that. And I'm looking at number 15 here. First, I'm going to take the -1 and put it at the end. You can or not. I mean, just a lot of people like that to be written at the end. And then we're going to have to factor that. So 2 cotangent, leave yourself a space, -1. And what are we going to have to factor out? 1/4. Good. Factoring out a 1/4 is the same as multiplying by 4. Good. Just the reciprocal. So that will give us what, x minus pi. That actually wasn't too bad. You take out the fraction, you're taking out the 1/4 x minus pi. All right, so if you want to block off the trig function, it's that part. So let's fill in the automatic stuff. Cotangent looks like those wiggly things. Oh, I shouldn't have told you that. Do you guys remember cotangent and tangent look like these? They look like cubic functions. So what's something we can fill in automatically? There's a few things. Range is good. Everything, all reals. Amplitude is none, unless it's sine or cosine. That's not, I probably shouldn't even ask it. The only reason I do is for you to get a gimme answer. All right, so just don't forget that. Now here's the big thing. The period is different for these. Instead of 2 pi over whatever, it's just 1 pi over whatever. And in this case, that's 1/4. So again, dividing by a 4th is the same as multiplying by 4. That would be 4 pi, which is kind of nice. Instead of 1 pi, now it's 4 pi. We took it and we stretched it, which gives you like more space. It's when you squish it together that it's kind of harder with the fraction. All right, phase shift. Did we go left or right? We went right pi. So you could just say pi or right pi, and that's what's going to go right here. That's where you always start. And then what's your vertical translation? Yep, down 1, or you can just say -1. You would get all that without even doing the graph. So let's get the f of x values. Cotangent is x over y, and remember, we're only going to go halfway around. So if we start here, x over y, 1/0, that's undefined. You can't divide by 0. Now we're going to take these rest stops because we're only going to go halfway around. I know these look weird, it's all root 2 over 2, but anything over itself is 1, times 2 is 2, minus 1 is 1. Now we're up here. 0 over 1 is 0, times 2 is still 0, minus 1, -1. Now we're right here. What does that give us? -1, good, times 2, -2, minus 1 is -3. And then the last one puts you back where you started. So undefined. So you always start with the phase shift and then you add the period. We said the period was 4 pi. 1 pi plus 4 pi, 5 pi. And I think we can just count by pi's, right? 2 pi, 3 pi, 4 pi. When you stretch it out, a lot of times that happens. You can just count by pi's, which is nice. No fractions, guys. So whenever you go to label these, just count each one as pi. And you don't have to label more than 2. I mean, that's good enough. I can tell what you mean. Fine. And then just plot all that stuff on there. So pi is an asymptote. And then we've got 1, -1, -3, and another asymptote. And again, I just want you to continue it for one more cycle. And just don't forget to go back and answer the domain. It's everything except where the asymptotes are. The problem is there's an infinite number of them. So what's the first one? Where did we start? Pi is the first one, plus however often they happen. So we have one at pi, and then 5 pi. So there's 4 pi in between that, so 4 pi n. For tangent and cotangent, that will be the period of the function. So for secant and cosecant, it's half the period. For tangent and cotangent, it's the whole period is what you add on. The reason for that is you get one full cycle in between the asymptotes. For these ones, do you see how there's an asymptote halfway in between? Like, that's why it's half the period. But for tangent and cotangent, you add on the whole period. Or you can always just look at the graph. So where'd my little sheet go? We did one of sine and cosine. We did one of secant and cosecant. We did one of tangent and cotangent. The others are on Schoology for you to practice and look up the answers. We understand that? All right, so I'm going to change this equation. There's not technically anything wrong with that equation, but I worked it out and it didn't like make sense in real life with the idea of a Ferris wheel, if that makes sense. Like you have to get in when it's on the ground and then it goes up. So like mathematically, there wasn't anything wrong with it, but as far as the problem goes, it didn't make sense. So I'm going to change this. As a heads up, the same thing happened on the test. So I'm going to change the one on your test too. I wish I had caught it before I hit print, but you know what? Life happens and we're all going to be okay. So please change it to that. And I'll just kind of stop there and give you a minute. The one on your test is about, oh, sorry. I did hit record. And I always forget because I can see it. The one on your test, this one's about a Ferris wheel going around. The one on your test is about temperatures throughout the year. So you know how it gets warmer in the winter and then, or warmer in the summer and then colder in the winter and then warmer in the summer and colder in the winter, it follows a wave. So again, the one on your test, like mathematically it was fine, but I had it like cold in August and hot in February. So I like was like, whoops, let me make this make sense. So just so you know, when I pass out your test, the first thing I'm going to do is tell you to turn to that problem and fix it so that it like is logical. Okay, because I want it to make sense. All right, so it says, what is the period of the function and what does that mean? We're going to put 2 pi over what? I know that there's like a whole lot in that equation, but it's 2 pi over what part of that? The pi over 3. It's whatever's in front of the variable. So it's 2 pi over 3. So that would be 2 pi times what? 3 over pi. Good, you're going to reciprocate it. So the pi's cancel. And what do we get? 6. Good. That's the answer. Now we have to say what it means. The sentence is always the same. It's the same as we did it in the notes. It takes, I'll get it started, see if anyone remembers this. Just jog your memory. It takes 6 and then minutes, years, seconds, whatever it is. It takes 6. What was the time unit? Minutes to do what? To complete one full cycle. That is the answer. On your test, that's the answer. Just instead of 6 minutes, it'll be whatever answer you got and then whatever the time unit is in the problem. So 6 minutes to go around the Ferris wheel once. That make sense? All right, what is the greatest height that the rider gets and the lowest? I would draw a little picture. Where are we centered? Look at the equation. Where'd the center go? Up 14, good. We're centered at 14. And I think it was feet, right? Yeah, feet. We're centered at 14 feet. And it's a wave. It's going to go up and go down and come back and all that. So you would add the amplitude and subtract the amplitude. So what's our amplitude for this one? 12. So you would add 12 to get the maximum. So 14 plus 12, 26. And then 14 minus 12 would be 2. The Ferris wheel can't actually hit the ground, you understand? It can't be 0. That would like be an accident, okay? So the maximum is 26 feet. The minimum is 2 feet. Make sure you put the minutes and the feet and stuff like that. I make it worth credit, so I have to take off if you don't put it. And you're gonna be bummed if you like miss points because you didn't put the feet in the minutes. All right, what is the rider's height after? And I had to change this too to make it work. Instead of 5, can you please make that 3? Because I changed the equation, so then I had to like adjust that as well. So what is the rider's height after 3 minutes? What we're gonna do is make a table exactly like we've done for all the other problems. And I'm going to ask you for a value that shows up on the table. I'm going to ask for one that will show up on the table. I'm not gonna ask you for something else different, okay? Now the Y values, you really already have them. We start at 14, and then it goes up to what? We're just pulling out all these numbers, 14, 26, back to 14, to 14. So those you have, if you drew this little sketch for yourself, you already have those, 14, 26, 14, 2, 14, 26, 14, 2, you know, it's gonna keep on going around and around. So these, you start with the phase shift. So look in here, we went right 1.5. So 1.5, and then we said the period was 6. So add the period. So 1.5 plus 6 be 7.5. And then you can just count by 1.5s. So 1.5 and then 3. And then 4.5, and then 6, and then 7.5. If you get confused on that part, draw a number line and you can just, you know, count your way to the middle. Remember doing this? Like just make a number line and just literally go like that. It'll take you to the center every time. So again, I would only ask you for one of these numbers. I'm not going to ask for something that's not on the chart. It's right here. At time 3, what's the height? 26 feet. And hey guys, your choices were 26 or what? What were the only other options? 14 or 2. So like, if you want to guess, those are the only 3 things that it could be. Okay. What are you saying over here? Exact 33 1/3% chance. All right. Now, I made some of these really hard. Again, I made them less hard on the test. You're going to have to factor these. I made all of these ones you had to factor so that we could practice doing that. On the test, I didn't make them all like that, okay? But let's go ahead and rewrite these ones that you have to factor. So looking at A, this will be 5 cosine of, and then leave yourself a blank. We're going to have to factor out the 1/4. Factoring out a 1/4 is the same as multiplying by 4. So if you multiply through there with a 4, the 4 and the 1/4 cancel. That's kind of the whole point. That'll just be x minus, all right, this is a half times 4 be 2, so 2 pi. And what I would do is kind of scribble this out so that you look at the factored version, because you want to look at that version of it. All right, this one doesn't need factored, so great. This one, I'm going to factor it, and I'm going to put that 2 at the end. You don't have to, but again, that just tends to bother people when it's out front. So I'm going to put the 2 at the end. So this will be -4 cosecant, leave yourself a blank, plus 2. And we're going to factor out a 2/3. Dividing out a 2/3 is the same as multiplying by 3/2. So if you multiply this by 3/2, the 3's would cancel and it would just be pi/2. So x plus pi/2. And again, my suggestion is scribble this out because you want to look at the factored one. Listen. All right, so looking at letter B here, this would be 9 sine, and then leave yourself a blank. We're going to factor out the 2 pi/5, which would be the same as multiplying by 5/2 pi. So this will be x minus, all right, if you do 5/2 pi times pi, the pi's are just going to cancel, and you'll just have 5/2. It'll just be the reciprocal. And again, my suggestion is scribble this out. All right, letter D, we're going to have to factor out the 2. So this will be 2 cotangent. Wondering if I'm going to have enough space. Let me try and write it a little bit smaller. All right, if you factor out a 2, that'll leave you with x minus, now it's already pi over 2. If you divide by another 2, it'll be pi over 4. Good. There, barely fit that in there. Bless you. And then last one, I'm going to take that 1 and put it at the end. And then we're going to factor this. So it'll be -2 secant, leave yourself a space, and then put the +1 at the end. If you want to, you don't have to. Just remember that's outside the function. That one's not too bad. Again, they're not all going to be really hard. What are we going to factor out of that one? Pi, good. And then what's left? Good. See, they're not all really hard. Some of them will be, but they aren't all. And same with these. That's my pep talk. Some of these are going to be kind of tough, but not every single one. Let's look through and find some that are maybe easier. Number 1, this function, and that means one of these, A, B, C, D, E, F, has the same period as the, okay, we would have to test every single one. So let's skip that. We'll come back to that. This function has a phase shift of -pi/2. Can you look through, find one that has a phase shift of -pi/2? And there's only one possible answer. It can't be like, which one? E. Do you see the x plus pi/2 there? Phase shift of -pi/2. So that one's E. This function does not have a vertical translation or a phase shift. So it didn't move up, down, or left, right. Which one is that? C. Do you see how there's like nothing added or subtracted in that? So see, they're not all going to be really hard. Let's see which other one wouldn't be so bad. The phase shift of this function is the same as the period of this one. All right, well, let's find the period of this. Careful, it's cotangent. So it would just be pi over 1/2. Good, so that would be 2 pi. So we want one that has a phase shift of 2 pi. So look through your choices. Which one has a phase shift of 2 pi? A, good. This function has a phase shift that's half its period. All right, that's going to be tough. I'll come back to that one. Oh, look at 6. It says the what? If it has an amplitude, it has to be sine or cosine. So automatically, this is going to be A or B, like flat out, okay? The amplitude is the same as the phase shift for this one. This phase shift would be 9. You'd have to factor out the pi, but you can see that it's 9. So which one has an amplitude of 9? B. See, they're not all really hard. Some of them are, but skip those, right? This function has, an amplitude. It's either going to be A or B. It is equal to the sum. What does sum mean? Addition, good. The phase shift and the period of function f. All right, so let's look at function f. What is the phase shift for function f? 3, good. And the period would be 2 pi over pi, would be 2. So 2 plus 3 is 5. Which one has an amplitude of 5? A. Do you see how 4 was A and 7 was A? Like, so you can use them more than once, right? And then this function has a vertical translation of 1. Well, which one moved up 1? F. All right, so see, they aren't all really hard. Now let's go back and get those 2 tough ones. Number 1, this function has the same period as this. All right, this period would be 2 pi over 6 pi over 3. All right, so we are looking for which one of these has a period of pi over 3. Look through. Well, it's not going to be this one because that has a 1/4. It's not going to be this one because that has a 2/5. You want to find one that has a period of pi over 3. Let's see. Good, it would be C. Tangent means you just put pi over whatever, and that would be pi over 3. So C, good. But you kind of had to look through all of them, so that one was tougher. And then last one, this function has a phase shift that's half its period. All right, look through and see if you can find a contender. I mean, there's some that wouldn't make any sense, but you kind of do need to look through all of them. Like, that's a hard question. That's why I saved it for last. Which one do we want to try and see? Well, this doesn't have a phase shift at all, so it can't be C. Let's look at D. All right, the phase shift is pi over 4. The period would be pi over 2. Good. A fourth is half of a half, so D. But that was hard. You'd have to look through each of them.